Hi, this is Xinyi. I'm going to talk about the modeling for 7075 supplement assignment. This include my computer modeling demo video. First of all, I'm talking about the first component, the form finding, base pavilion surface circles. The input is the surface I created in Rhino and set as initialized data. And by putting the points onto the surface using Kangaroo plugin to put the points using colander, create the interaction forces between the curve and the surface, and evaluate the points on the curve, which get us the UV point coordinates of the curve of the points, and evaluate the surface, and we get the circles on the surface. The second component is to find the pavilion surface polygon meshes by scaling the original surface and put it onto a XY plane, which we called it a reference plane. By putting the points onto the plane, creating meshes on that, and then map the mesh onto the pavilion surface. Also use Weaverbird's plugin to get the tiles, and then use dual plugins to get the polygon of the surface. And finally, we got the outlines, which give us two outputs. One is the naked edges, and one is the initial, that's the naked edge, and the other is the internal edge. Component 3 is detailing the segmentation curves. By exploding the curve, pull the curves onto the outer naked curve, and then remove the duplicated lines, getting the endpoint. We get the recreated points along the naked curve, and then we dispatch these curves into two sets of lines. First one is the edge segment curves that connected the interior curve with the outline curve. Second one is the interior segment edges, which is purely interior polygon edge. And then we come to the component 4, the interior polygon pipe structure. By getting the points, remove the duplicate points, and then recreate all the lines. We got the pipe structure. And there's two demos we can change for this. First of all, we can always change numbers of the points on the curve. So the more the points, the more detail of the pavilion. So we set it to 100. The second one is the circle radius. The bigger the radius, sorry, 1 second, it's a bit crashed. The bigger the radius, the bigger the circle is. So we can see the circle radius getting bigger, which gave us bigger mesh areas within the surface. And the ideal number will be around 6. So we set that to 6. And the smallest it can be is 5.5, which give us reasonably completed shape. So the next one we can change is the pipe thickness of the final pipe structure. It can change from 0.1 to 1. Of course, it can get bigger, but it's just a basic pipe structure for the future modeling to shape the pavilion surface. So yeah, that's it for my computational model. And it's it for the demo video. Thank you.